Hey, what's up, Elge2? Just one little quick thing here. We are starting Unit 9, so this one does say 8.1. It is 8.1 out of the book, but how we have kind of navigated through everything, we are making it Unit 9, so that's cool. We're starting out with this whole unit's on rational functions. We're not going to get into the graph of it, so to speak, but the process... it is the math and everything behind it is what we're going to be reaching at here. So when we go through and work on things, we are going to be rationals are fractions where we're dividing by x. So if you think about everything that we've done so far, mx plus b is linear, x squared, parabola, quadratic. Exponential, we just talked about, has the asymptote, never quite reaches 0, but that's when it's 3 to the x, the exponent is x, and then now we are going to look at when we have over x. So we're going to be dealing with fractions. Might want to just quick revisit how to add, subtract, multiply, and divide simple fractions because we are going to get into some crazy things. Also, you might want to go back and review factoring. Yeah, those of you that thought unit stuff from October was no longer valid and I'm just going to forget about it, it's over and done with, I survived factoring. And then it reared its ugly head when we did quadratics and we still had to know how to factor. Yep, welcome to rationals. Got to know how to factor. That's why we spent so much darn time on it. So go back, review some things. I'm not going to have a review video. So when we get to that stuff, that's going to be on you. Okay, so a couple things I want to quick take a look at, and then we'll jump through here. Direct variation. All right, direct variation here is linear. All right, as you can see from the equation here, y equals kx, that's mx plus b. Inverse variation is what we haven't really learned about. That's the process here. That's rational. And then joint variations are mixed. Or with three variables combined as when it's mixed could be inverse and directly variated. So the big thing, as you're going to hear me say, is find out k, use k. Find k, use k. Find k, use k. Find k, use k. Your biggest thing is which formula are you going to use? Okay, so as we go through here, we're in direct variation. So the equation we're going to use is y equals k times x, right? And it is just asking us to write the equation. So that's no big deal, right? They give us what y equals, give us what x equals. So you take and substitute those values in. Negative 24. Is equal to k times 4, not 6. Divide both sides by 4, and you get k is equal to negative 6. So then it's asking us to write a direct variation equation. Well, all you need to do is find k, and then you need to use k. And as you can see, y equals negative 6x is a linear equation with a negative slope. You would start at 0, go down 6 over 1, down 6 over 1, life's all good. Okay, so direct variation, think in your head linear. So that's all it's asking us to do. All right, now we get into example 2, and it's saying the amount of money earned varies directly. All right, those are the keywords you want to look for. So amount of money varies directly to the number of hours worked, so k times h. All right, money is equal to k, which is what we're going to try to do and find, and h is hours, right? So if we break this up into two parts, find k, use k. All right, so varies directly. Julia earned $116.25 for working 15 hours. How many hours did she work if she earned $178? So the first thing that we're going to do is we're going to find k. We're going to take the amount of money she had is equal to k times the amount of hours she worked. And then since this is a nice simple algebra equation, you're just going to take and divide both sides by 15, and then you are going to get 7.5. So you get what K equals. All right, so we found K. Now we have to use K to make an equation to answer that question. How many hours did she work if she earned $178.25? Well, our new equation, now that we've found K, which is basically the amount of money she earns an hour, right? That's what we found out. Oops, not K, but we're multiplying it by the number of hours she worked, right? And then in here it says how many hours did she work, so we're solving for H if she earned 178. So you take the values, plug them into the correct spot, and solve. We're solving for hours in this case, so you're going to divide both sides by 7.75, and you're going to get the number of hours worked is 23 hours. So she worked 23 hours to make that $178.25. All right, let's go down to inverse variation. Okay, inverse variation is a different equation. So it's the time needed to complete a race varies inversely. So that's, again, the key word that we're looking for. So we're thinking y equals k over x. All right, so we're going to be dividing by x. In this case, we can even put, instead of y and x, we can actually use some variables that make sense. So it's saying time varies inversely. So time equals k, which is our constant of variation, that's the name for it, over speed. If a runner with an average speed of 8.82 miles per hour completes the race in 2.97, what is the average speed of a person who took 3.5 hours? So we are going to find K, and then we're going to use K. Okay? So take the values they give us. If a runner averages speed of 8.82, I'm going to put that down here, and it took them 2.97 hours, we are going to solve for K. So you're just going to take and multiply. Since we're dividing by 8.82, we're going to multiply by 8.82 and get 26.1954. So now we're going to, after we found K, we use K. Time is equal to 26.1954. I'm not going to round because it's only 4 decimal places, so it's pretty easy to use, right? And now it's saying, what is the average speed? So we're going to solve for S when they took 3.5 hours. So we're going to substitute that in for T. And then we're going to reach back on our knowledge from 6th and 7th grade math. Think of that as a proportion. Cross multiply and divide. Right? I'm not going to show this step every time, but we're going to cross multiply. So 3.5 times S equal to 26.1954 times 1. Then divide both sides by 3.5, and we get a speed of 7.4844 miles per hour. Okay, so look for those keywords because now we're going to go into joint variation. All right, joint variation has multiple variables going on, so things like area and volume formula. Well, actually, it would be more areas formulas than volume because volume you might have to add some things and whatnot. So volume would work. I'm thinking surface area. Sorry, I have geometry on my head too. We're doing surface area and volume in geometry, so that's why stuff's bouncing out in my brains. But it's saying volume varies jointly. So we're going to have multiple variables. So volume varies jointly. So we're going to have K times as the area of the base, B, and its height. So B and H go together, multiplying all it out. So now we have to go through and find out K. It's saying if volume is equal to 12 pi feet cubed and B is, or the area of the base is 9 pi feet squared and H is 4 feet, we want to find out B when they give us all that other information. So what we need to do is we need to find out what K is. And that's just my printer going off. My lovely wife is printing something right now. So I apologize for the background noise. We have K times 9 pi times 4. All right, so we got 12 pi is equal to 36 pi times k. If we divide both sides by 36 pi, the pi's cancel out. 12 over 36 reduces down to 1/3. So my equation for volume, which is a true equation, if you don't believe me, look it up. 1/3 area of the base times the height. So now it's saying find out B. So now we're on this bottom part. Find out B when the volume is 24 pi. Don't know B, but we know the height is 9 feet. All right, simplify the work and the sides down. 1/3 times 9, or 1/3 of 9 is 3. So 3B. Divide both sides by 3, and you get 8 pi is the area of the base. Things I could ask you then, what is the radius and stuff like that, and then we'd have to go through and make a new equation and all that kind of good stuff. All right, combined. These are kind of put together with two different things. So it's saying the volume V varies inversely, so we're going to write that fraction with K on top, pressure on the bottom, and directly as temperature. So I'm going to put T on the top. I'm going to put it in red because it's in red, right? So we have two different things. We have something that's varying directly, which is multiplying on top, and inversely with the fraction on the bottom. Now it's just a matter of, again, still substituting in to find K and using K. So if the volume is 20, we need to find K. They give us a temperature of 320 Kelvin over a pressure of 1. Whoa. I'm not going to put that other K in there. I don't even know why I did that. Okay, there we go. That was for the Kelvin, but I don't know why I wrote it. All right, so now we're looking at 220 is equal to 320 times K. Divide both sides by 320. And you get 1/16. I reduce down 2 over 32. All right, now that we found K, we are going to plug it in, and we are now going to use K times temperature over pressure. So it's saying, what's the pressure? So we're going to solve for P. If they give us the volume is 15, K is 1/16 times the temp over P. So then I would simplify the top of that fraction down and get 15 is equal to 20.625 when I multiply the 1/16 by 300 times P. Cross multiply and divide, you get the pressure to be 1.375. All right, so why don't you guys go through, read number one, you try number 1, pause that video, try it out, and then we'll go over it. All right, so since we're reading this, last trimester, 8 of Mr. Ness students built a 7-foot sailboat in 195 hours. The time it takes the group of the students to build a sailboat varies inversely. So time varies inversely as the number of students. So we have time varies inversely to the number of students. How many hours would it take 12 students to build the same boat? So what we need to do is we need to find K. They give us the time of 195 hours. And we got to find K. We know 8 students worked on it. Multiply both sides by 8. And we get a grand total of 1,560. So now we're going to use K. And it's saying how many hours would it take 12 students? So we're going to take time, take our 1,560 that we found for K, divide it by 12, and time is 130 hours. Okay, so what you're going to see for homework this week, starting this week, is there's going to be an assignment posted. I will have an answer key made. So you're not going to submit these assignments
expectation is you're still going to do them because now you're going to get that instant feedback right away. And then the end of the week quiz is going to be what is going to be graded going into the grade book. Okay, so you have that time, look up those answers, and whatever. I'm still going to have Thursday sessions, so that's going to be all good. Enjoy your rest of the day, folks.